with a new chapter, and it's the last chapter of our class 10, probability. We have completed all the chapters, all the syllabus, and it is the last chapter of our class 10. And whenever we are doing this last chapter, this thing also coming in mind, few days are left to start our pre-board examination. Before that, some practice classes also will be there, don't worry for that. But let's start the class probability. And very interestingly, the probability which you have learned in class 9, class 10 probability is not so far different from that. It is very related to that only. Now also you are not going to get the conditional probability. These probabilities are actually unconditional, experimental probability. In our syllabus, experimental probability, unconditional, that one we will learn. But actually in our real life, what the probability is actually applying, that is actually conditional probability. However, so many things are there, so many parts of things are there of probability, like as binomial distribution, Newton's law, like that thing, so many things are there. But these are for the higher class. Class 10, we are very safe. Our probability is experimental probability. What the formula, what the technique we have learned in class 9, the same technique, same formula will apply here also. So before to start this chapter, I am just reminding you all those things which you have learned in class 9, because that is only the syllabus of class 10. First of all, probability means an event will happen or will not happen. The chance we are finding out by that. Now, question is that what is event? So to explain that one, I need to take one example. At first, I need to take one example, and through that example, not only one example, two examples I will take, and through that examples I will show you what is the meaning of experiment, what is the meaning of event, what is the meaning of outcomes, what is the meaning of sample space, what is the meaning of event space. This all the things will explain, and we will complete the sum. And after that, we will go for the different formula, so that it will become a clear concept for you all regarding the probability. So, first of all, we are choosing an experiment. You remember, probability we are finding out for an event, and event is a part of experiment. Probability we are finding out for event, and event is a part of experiment. So, I have to choose one experiment first. Suppose we are choosing the experiment throwing two dice simultaneously. Dice means ludo chokka. Jodio এটা plural form. Plural. This is actually die is the singular form. D-I-E. And D-I-C is actually the plural form. Okay, two dice we have thrown simultaneously. So we have to make one checkerboard for this. This is suppose the first die, and this is the second die. Whenever I have thrown the first and second die, what are the outcomes are coming, that one will write here. See, I have used the word outcomes. What is the name of the experiment? The experiment is throwing up two dice simultaneously or together. Now, if I throw only a single die, what are the outcomes will be? If I throw a single die, what are the outcomes will be? 1, 2, 3, 4, 5, 6. All of you know, ludo chokkaয় 6টাই থাকে। 6 পড়লে খুশি হয়, 2 পড়লে কষ্ট হয়। So, whenever you are throwing a dice, then out of the 6 outcomes, any of the outcomes you can offer. So, what are the outcomes are there of throwing a die? 1, 2, 3, 4, 5, 6. So these are the outcomes. If I throw the second die, this is also single die. So there also the outcomes are 1, 2, 3, 4, 5, 6. No any other type of outcomes you'll get. Whenever I throw the first die, I'll get 1 to 6 any of the number. Whenever I throw the second die, I'll get 1 to 6 any of the number. Now let's combine. Let's see how many types of occurrence are possible. Whenever two dice we are throwing simultaneously. Whenever we are just throwing a single die, then I'll get 1 to 6 any of the number. But whenever two dice we are just throwing together or simultaneously, then total how many outcomes are coming? Let's see through this table. It can possible first die we have got 1 and the second die 1. First die 1, second die 2. First die 1, second die 3. Then 1, second one 4. Then 1, 5, 1, 6. 2, 1. First die I got 2, second die 1. So like that any of the outcome may can occur. So these are whatever we are writing, these are the all outcomes for this experiment. 2, 3, 2, 4, 2, 5, 2, 6. Then 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Then 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And at last 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So total how many outcomes? Here 6, here 6, here 6 is the 36 outcomes are there. So I can write here total number of outcomes equal to 36. So these are called outcomes. Okay? And what I have written here, this is actually the sample space. Sample space. So whenever we are writing experiment related all outcomes, that is actually called the sample space. But do remember, in the sample space, same thing should not be occurred twice. Whenever we are writing the sample space using a set is actually a collection of defined distinct object. So no need to take it as a it will become complex for you. Let's study this one first. Then I will give you the concept of set later on. What is this? Experiment related outcomes. Whenever you are writing together, this is actually called the sample space. I think you can remember. Whenever you are doing an experiment related all outcomes whenever you are writing, that is called the sample space. And in the sample space total how many outcomes are there I can see easily. So this is the number of outcomes I have written here. Okay. Now thing is that the question we have to supply some event. Then only you can find out the probability. So giving the event. First of all, event 1. This event will be given in question. Suppose I am giving you the event to get doublet, event 2 to get the sum on 2 dice greater than or equal to 7, event 3 to get the sum divisible by 3 or 4. Okay, 3 or 4 I have written, 3 and 4 I have not written. Okay, what is the meaning of 3 or 4? Either it is divisible by 3 or it is divisible by 4. And if it is written and, then it should be divisible by 3 and 4 both. Okay. Now for this 3 event, we would like to find out the probability. So how to find out? So do you remember we are finding out the probability for an event. Now let's see the formula of probability. What is the formula of probability? Probability of an event. This one how we have read it? We have read it as probability of an event. Okay? Probability of P of E should be read as probability of an event equal to number of outcomes of the event by number of outcomes of the experiment. Total number of outcomes of the event by total number of outcomes of the experiment. If I do so, we will get the probability. So let's do here. First one, to get doublet. So we are finding out probability of getting doublet. What is the meaning of doublet? If both the die will get the same number, that is called doublet. Let's see. 1 1. Both the die same number. 2 2. 3 3. 4 4. 5 5 6 6. No more are there. Both the die have the same number, only this 6. So total how many outcomes are there? So related to this event, what event? E1 event we have given to get the doublet. So related to this event, number of outcomes are 6. So related to the event, the number of outcomes are 6. And related to the number of outcomes of the experiment, related to the experiment, how many outcomes are there? 36. So it will be 36 by 36. So the probability will be 1 by 6. I think it is clear. Always you have to simplify to give the answer. The formula was number of outcomes of the event. So event related outcome I have 6 written, and below it is number of outcomes of the experiment. Experiment related outcomes are 36 written and simplified. And one thing I must say here that what is experiment I have explained using the example. What is event you understand? Event will be given in question, then only you can find out the probability. You are finding out the probability not for an experiment. You are finding out the probability for an event. And an event occurs under an experiment. Until and unless you do the experiment, you will not get the event. And you are finding out the probability of an event only. And what is the formula to find out the probability? Probability of an event is the total number of outcome of the event by total number of outcomes of the experiment. What is sample space? Experiment related all outcomes should be considered as sample space. All the samples which can be occurred from this experiment are to be written here. So sample space is all the outcomes of an experiment. Now question is that what is event space? That I have not discussed. So event space, what is this? Experiment related all outcomes is called sample space, and event related all outcomes are called event space. So if I want to write the event space, it's not necessary to write, just for your understanding I am writing here event space. Number 1, this is 2 and this is 3. For the first question, if I write the event space, one, look here, look my left hand, 2, 3, 3, look my right hand and left hand together, 4, 5, 6, 6. So these are the event related outcomes. So this is called the event space. So don't mix the event space and the sample space. Sample space is the experiment related outcome, and event space is actually event related outcomes. Clear? Acha, one thing just you can see that event space, whenever I have written, I have given the second bracket. There are two ways to give the space. Event space, once I have written here in the second bracket. Okay? Sample space also I can write in the second bracket. So to represent the space, either it is an event space, either it is a sample space, either you can apply the checker rule or you can write like this. But whenever you write like this is called the set representation. Both sides we have given the second bracket now, this is called the set representation. And set has defined by actually D. Cantor. What he has defined? He has defined that a set is a collection of defined distinct objects. So whatever the objects must be kept in the set, they all must be defined, they all must be distinct from each other, different from each other. You just see, whatever I have written, they are all different. If there it is written 5 5 twice, I will write only once, not twice. If it is written 3 3 twice, I will write only once, not twice. But I'll count them all. For example, suppose here 5 5 twice came and 3 3 twice came in the sample space. But whenever I write the event space using the second bracket as a set representation, I'll write 3 3 and 5 5 only once. But whenever I count total number of outcomes, I'll count this as 8. Because now it is 6. Now 3 3 twice is there and 5 5 twice is there. So total how many is coming? 8. Am I clear to you? Event space doesn't mean that you have to always count from here on to get the number of outcomes of the event. Actually occurring outcomes how many? That one you have to count. If I do more examples, I think you can understand better. So this one you understand? Second question, what is that? To get the sum on two dice as greater than or equal to 7. This is our second question. Greater than or equal to 7. So sum on two die you have to do. You have to check either it becomes 7 or more than 7. Here how much coming? 1 plus 1 is 2. Is not 7. 2 plus 1 is 3. It is also not 7. To remember, this sample space having a good character. What is the character? Right diagonal elements addition always 7. You just check 2 plus 1 what? 3. This diagonal you check, always you will get 3. If you do the sum, here also see 3. Here you see 3 plus 1 4. You see this diagonal. This is also 4. This is also 4. So once whenever you are checking, this cannot be taken. So this diagonal you don't check because everywhere it will be 7. We need to get minimum 7 first. Then only we will go for greater than 7 because greater than or equal to 7. So we have to take all those values wherever the sum is coming 7 or more than 7. So here the 5 plus 1 6. So up to this we will not take. See 6 plus 1 7. So this one I will take 7 or more than 7. So now I will not count from here. Now I will count from here. 6 plus 2 is 8. So 6 plus 1 7 means this one, this one, this one, this one, this one, this one. All are 7. So this diagonal all we have to take. 6 plus 2 8. So this one also we have to take because greater than 7 is also there. This one can be taken. This one can be taken. This one can be taken and this one also. So how many are coming? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So second one, directly we will find out only the probability of getting the sum greater than equal to 7. You need not write the event space always. So it is coming 21 by 36. Cancel by 3, 7 by 12. Because event related outcome is 21 and experiment related outcome is 36. Now the third one what has given? To get the sum divisible by 3 or 4. So either it is divisible by 3 or it is divisible by 4. So let's see which one can be taken. In the time of exam, use pencil to underline this and after that you just rub it using the eraser. Divisible by 3 or 4. This is sum is 2, not divisible by 3. This is divisible by 3 because total is coming 3. So this can be taken. This is divisible by 4 because sum is coming 4. This cannot be divisible by 3 or 4. This is divisible by 3. So this diagonal will be taken. This cannot be. This is divisible by 4. So this diagonal should be taken. This is divisible by 3. So this diagonal can be taken. This one cannot be divisible by 3 or 4. This is also cannot be. This can be divisible by 3. So how many are coming? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20. So probability of getting the sum divisible by 3 or 4 equal to is coming 20 by 36 by 4 cancelling 5 by 9. I think you understand the sum. Okay, so moving for another example. Today also we will not start the exercise. We will go for another example now. Now moving for another experiment. tossing up, the tosser coin will get either head or tail. Here three coins we have to do, but add together not possible. So doing the first checkerboard, I've taken the first coin and the second coin. If I toss the first coin, I'll get either head or tail. If I toss the second coin, I'll get either head or tail. Now if I combine them, head head, head tail, tail head, tail tail. So whenever you toss two coins simultaneously, either we get in the first coin head, second coin head, first coin head, second coin tail, first coin tail, second coin head, or both the coin tail. Now we have to take the third coin because three coins are here. So first and second we have taken together here, and this is the third coin. First and second total how much we have got in the first checkerboard, so that I will write here. Head head, head tail, tail head, tail tail. And by tossing the third coin, I will get either head or tail. Now combine them. Head head head, double head tail, head tail head, head double tail, tail double head, tail head tail, double tail head, tail tail tail. So total how many outcomes are coming under the lesson after doing the tossing, after tossing the three coins simultaneously? Total how many are coming? 8. So what will write here? This is actually the sample space. We are not writing again. Already explained. So number of outcomes 8. Now event should be subtracted to find out the probability. So first event we are giving to get no head, event 2 to get at least 2 head, event 3 to get at most 2 head. Actually, to know about the meaning of at least, I have written like this: at least and at most. So okay, first event we are taking probability of event 1 to get no head, no head. No head is here. Which one? If you are having one head, this is having no head. Correct? So only one outcome is here out of 8. So event related outcome is 1. Because no head, this outcome how many? 1. And experiment related outcome how many? 8. So probability is 1 by 8. Now for the next one, probability of event 2. At least 2 head. That's the minimum 2 head. Maximum I don't know. At least 2 head means you have to take minimum 2 head. Less than 2 head you will not consider. Understand? Suppose I have told that you can eat at least 2 rasgulla. So minimum 2 rasgulla you can eat. Okay, you have to eat at least 2 rasgulla. That's means you have to eat minimum 2 rasgulla. You have to eat. Maximum how many you will eat is your choice. The same way, at least 2 head. So minimum 2 head you have to take. More than that you can take, but less than 2 you cannot take. So at least 2 head you can get. At least 2 head. At least 2 head. But here 1 head, so you will not take. At least 2 head. Here 1 head. Here 1 head. That no head is there. So how many are coming? 4. So it will be 4 by 8. 1 by 2. Very easy to do. Next, event 3. To get at most 2 head. At most means maximum. Maximum 2 head. You cannot go more than 2. You have to take less than 2 or 2. Suppose I have told that you can eat at most 2 head. 2 rasgulla. Here too you are just eating of mine. So you have to take at most 2 rasgulla. That means you can take at most 2 rasgulla. That means what? More than 2 rasgulla you cannot eat. And that's why maybe your facial expression also changed. It's very bad. Whatever it is. So at most means you cannot cross that limit. So either you will take 2 head or less than 2 head. Understand the meaning of at most? So once you see the video twice, this portion, to understand the at least and at most. At most means you cannot go more than that. That is the maximum boundary. You can take less than that. So let's see. More than 2. We will not take. More than 2 head. No, we will not take. This one you can take maximum 2 head, maximum 2 head. You can take this one less than 2 head. You can take this one maximum 2 head, less than 2 head, less than 2 head. This one also can be taken, no head. At most 2 head means what? Maximum 2, minimum they are not 12, you can take 0 also. So total how many outcomes are coming? 7. The probability is 7 by 8. Clear? With this only we are concluding the class here today. Tomorrow we will start with another 2 examples first, then we will enter in the exercise.